Hello, what is up everyone, Tony here, and today I'm going to show you how you can set up your very own Huginn instance using Amazon EC2. So for those who don't know, Huginn is a very convenient automation tool that you can use to read websites, process events, get email alerts. It's basically very similar to If This Then That or Zapier, except it's self-hosted, it is expansible, and it is written in Ruby. So I figured, since most of you are probably home and wondering what to do with your time, why not spend some time on de-googling yourself or getting into self-hosting. So in this video I'll show you how you can set up and configure Huginn on a VPS of your choice. For this video I'm going to use Amazon EC2 just because it's quite popular, and there's also a free tier that you can use if you just want to play around with it. Without any further ado, let's get started. Alright, so let's get started with setting up our Huginn instance on Amazon EC2. So to get started, first I've already logged into my EC2 console, or AWS console. So I'm going to go with an Ubuntu 1804 image. And if you guys need help, a lot of this is very similar to the default installation that is listed here. So for instance, I'm going to go with a T2 small instance. So this will at least give us 2 gigs of RAM, which should be enough to run Huginn in a decent configuration. It is not necessary, you could run it on a smaller one. If you're just going to have a lot of recurring tasks, it will start to struggle after a while. Alright, let's go to the instance details. We want one instance. We don't want to terminate on shutdown because we might have to restart a couple times to get our unit working. For our case, I'm going to go with a 20 gig SSD. You don't need 20 gigabytes, but it will help because we have a lot of Ruby modules to install. So because Huginn is programmed in Ruby, we will have to set up bundler, and that'll take up a while. So we don't need any tags. I'm going to make a security group. Just make a new one. So we want to allow SSH. We want to also allow HTTP. And if you were running this on an actual domain name, you would want HTTPS. I'm not going to have this on any professional domain. We probably won't end up using it, but I'll make a video on how to use Let's Encrypt. Alright, so we can now launch. And I will just use my Tony tutorial key pair. If it's your first time, you can make a new key pair and then you just have to download it. You will need it to be able to use SSH to connect to the server because it will be set up with public key encryption. Alright, so let's go to view instance and let's wait for the instance to spin up. And meanwhile, I'll just make sure I'm captured properly. I will launch my terminal program of choice, which in this case is console, even though I'm on XFCE. So, okay, so our instance now says it is running. So we just can use the same command that they would use to connect. So I saved mine in documents in an AWS tutorial. Let's just connect. Oh, yep. We need to do a chmod 400 on our key file because it needs to be read-only. And there we are. We're logged in as Ubuntu on our instance. Now we can follow pretty much directly from the installation. So yeah, we will want to just do I'll just use apt instead of apt-get because I find it will work better. Sudo. Next up, you'll want to do an apt upgrade. Well, what you can do is you can do sudo -i, and that'll just drop you to root. Is it bad practice? Yes. Generally, you should run things as sudo if possible, because it'll also make sure you don't end up accidentally running anything else. Also, every call to sudo will get logged to your system journal, whereas if you're root, you can go a little bit more willy-nilly and mess things up. We won't need to install sudo, it is installed by default on Ubuntu. In their installation guide, they install editor, and then they set the default system editor as Vim. That's not necessary. You can use Nano if you are more comfortable with it. If you like Vim, you can go ahead and use Vim or Emacs or any text editor of your choice. Alright, so we're just about wrapping up this install or upgrade. And I apologize if our console. Okay, so we see that grub menu. We want to keep the locally installed version. That's the one by EC2. We don't want to override it with some package default. We can just install the list of requirements. I'm gonna leave, and I will just update their command to use apt instead of apt-get. So going over the quick list of essentials, we are installing RUnit because the way Huginn uses Unicorn to pass tasks and stuff, it relies on RUnit to start and stop tasks. Now, if you have systemd, you will need RUnit-systemd. Alright, just waiting for the install to wrap up. There we go. So that's good. Now we can go ahead and install RUnit, or install the systemd hooks. Alright, now we have to install Ruby. Their technical installation guide tells you to remove any past version of Ruby. We don't have any installed, so we don't have to worry about that. I will go ahead and compile Ruby 2.6.5. Now, at the time of writing this video, this is not the most recent version. Ruby 2.8 is out, if I recall. But I have found that so I was initially doing this on an Arch Linux machine. You will have to downgrade to 2.6.5 to be able to actually build and run Bundler properly. Otherwise, you will just get errors which aren't very well documented, but it's because the version of the gems you're trying to install will be off. Okay, wait for it to configure. Alright, now onto the compiling phase. This is only a single core machine, so this might take a little bit. There is, if you can just Google Ubuntu Ruby and then someone has it in their repos, and you could just use the binary version. You don't have to. Just do be cautious if you're using other people's repos because they're not always vetted. I'll pause for now and we'll continue. Alright, so our compile version has wrapped up, so we can now proceed with the rest of the installation. Alright, now we just have to do a sudo make install. This is very standard, usually always go /configure make install. It's how you install, fortunately, most compiled programs these days. So now we just have to install bundler and foreman, and let's update the Ruby gems. After this, where we get into the system user and everything that we actually do for the Ruby install, then it starts getting a lot more messy. So we are going to add a user with no login shell, because this user will never have to log in over SSH or anything. We just need someone to run the processes. And we are going to use MySQL as our database. So you'll want to install MySQL Server, MySQL Client, and MySQL Client-dev. This will probably install MariaDB, which is the MySQL implementation that is most common these days. There are a couple others, but they're not quite as common. I'll do the secure installation script. So you should always run this when you install MySQL. At least like this, you can use it to disable remote login and change the root password. So we can use the validate passwords. We just want something, or even low. This is a test server. On your server, you should make this more secure, but I'm gonna destroy this instance in an hour anyway. So let's set a password. Alright, yeah, it's secure enough. We want to remove anonymous users. We want to disallow root login remotely, and we want to remove the test database. Yes, reload. Alright, so now we need to go ahead and make a user, or alternatively just call it with sudo, and that way you'll use the Unix authentication. It's quite interesting because there are two ways to log into MySQL, and you can change this because I've had issues with it over the years. By default, MariaDB MySQL will use Unix authentication. That means you will use the root password on the server to log in, or you will authenticate as sudo or as the root user. This is in contrast to if you let MySQL handle authentication on its own, then you will have to use the password you just set. If you set a password in the MySQL secure installation, it won't work because you're probably using Unix authentication. Alright, so we are going to now make a user for Huginn. So this is standard MySQL syntax. We want to create a user, Huginn at localhost, and we just make a password for it. I will generate a random password with KeyPass. Let's make something not too long. Alright, let's just paste this in here and save it somewhere. Again, I don't care that you guys see this. Now, what the official instructions recommend that I've never had to do is to set the default storage engine to InnoDB. I've never had an issue with it, but I guess we can to be on the safe side. Now we want to grant permissions to the database Huginn production to our user. So we want to grant select, insert, update, delete, create, drop, index, alter, log. At this point, this is what the official instructions recommend. I don't know why they don't just go grant all or grant star. Like, just you're going to use all the permissions anyway. But let's just stick to the official route. Mostly because I won't be here to troubleshoot if your installation fails. So you will notice that we are giving permission to a database called Huginn_production. Now, the keen-eyed among you might have noticed that we haven't made a database called Huginn production. It does not exist. Let's exit. I guess you can use \q if you prefer. Now we can try connecting to it, and we'll get an error because the database does not exist. Let's take the password we created. Yes, unknown database. So the first time I did this, I made the database myself. You don't need to. The Ruby script that will run will create a database for you. Alright, now we are getting to the tricky part. Well, now we actually have to install Huginn properly. So first we need to do a git clone, and then we can just cdn. We copy the example env, and we can use a text editor of your choice. So Huginn by default runs on port 3000. Just take note of it when you go to install nginx or Apache, or whichever HTTP server you decide to use. You will need to know this so that you can reverse proxy it, so that incoming connections on your, I use a virtual host for it, but you just want to make it so that your incoming connections will get routed to this internal port. We'll edit the .env file later. Next we make the log, temp, process IDs, and temp sockets folders. And we will give control over these folders. So channel will change the owner. So if you do an LL, you will see that each folder has, this is the owner user, and this is the owner group. This implies the permissions. So the D stands for whether it is a directory, a folder, or if it's a file. If it's a file, it's a dash. If it's a folder, it's a D. Then we have RWX, RWX, RWX. So this first one is read, write, execute permissions for your user, or the user that owns us, in this case Huginn. So if we look at this folder, we see that Huginn user has read, write, and execute permission on it. In this case, the user Huginn has read and write access, but it cannot execute the file. The second set, this is the group, so every user also has a group that they belong to. By default, the group name will be the same as the username, but if you were like a school, you could have a group called students, a group called staff. Most Linux systems, well, historic ones, used to have a group called wheel, which used to be the group of users that would get sudo access, or the list of administrators. So the next RWX signifies the permissions of the group. So in this case, you can see that the group Huginn has read and execute permission, but it does not have write permission. So if this was a group called students, and this was your student's name, they would have read, write, execute access, the student, but the other students would be able to open the folder, run stuff, but they will not be able to save any changes to the folder. Finally, the last RWX is everyone else on the system. So people that are not part of the group and people that are not that user. So if we had a folder called staff, and you had a folder called report cards or something, and you left this R, that would mean any student or anyone else on the system could look into that folder. So the first thing we did was we gave permission of the folder to the user Huginn. To define a group, you could also go Huginn:Huginn. By default, it'll just take care of it. The second thing we ran is this, the chmod-r u plus r. So what this does is u plus, so this is user. The plus indicates that we are adding read, write, and execute permissions to the user. And for the group, it's a minus, so we are taking away write permission. So if you didn't define u or w, if you just did sudo chmod plus x, for example, you would give execute permission to all three. Now, I personally, instead of doing this, would just do this by hand. So this would be octal, so for the user, you want everything that would be a 7. The first digit is the read, second digit is the w, and the third is the x in binary. Just convert that to octal. So if we wanted read and execute, that would be a 5 and then a 5. If we wanted everyone else is able to read but not execute, it would have been a 4. If we wanted read write but not execute, it would have been a 6. So that is how a very quick intro to how Unix permissions, file permissions work. Let me know if you want a separate video on Unix standards and such. Alright, now we will make sure our permissions are set. And we will change the owner of .env to be, or to allow read access to the user Huginn. So you might have noticed that we ran a command here called sudo -u Huginn. This is usually different than how you would normally be running sudo. So normally when you're on sudo, it's because you want to be able to run things, execute things as the root user. So sudo -u Huginn tells us instead of executing this as root or as the super user, we want to actually execute this as the user Huginn, which is what we want because Huginn owns all of these. If I was to do a sudo and I did any command here, it would change the owner of that file to root, and that would mean that Huginn will no longer be able to open it. Like, you could run Huginn as the root user, you shouldn't, because generally you want to give as little permissions as you want. Huginn has no reason it should be going around the rest of your server. Okay, now we can edit our .env file. What concerns us now is this database connection. So our database name is Huginn production, and our username is Huginn. You should never log into my school as root. And our password is what we just set. We can choose to single quote it. Otherwise, this all looks good. We don't want to force SSL. We do want to change the invitation code so that random bots on the internet don't just start spamming accounts. We also want to set Rails env to be production. The rest of this you can change. For example, you can set up SMTP for the email agent. I have personally been fine. In fact, I had some issues with SMTP authentication. That's not an issue. You can use any email sending API, so for example SendGrid or SMTP2Go, and they will take care of sending it for you, and you just have to send an API call. That works as well. Alright, so first up you want to copy, or not first up, next up you want to copy the unicorn configuration, and we can just open it in our editor of choice, which in this case is Nano because it works. So we don't actually have to change anything. The Rails env is set to production, that's all good, but by default you'll notice that we have 2 worker processes here. If you are running this on a really crummy server, you will want to change that to 1, just to make sure that your system does not get locked up. Alright, now we have to install all of our stuff, and you will notice that this frequently results in errors. I could not find a bundler, but you need to be careful because if you run bundle update -- bundler, you will install a bunch of stuff on your computer. Instead, we can install the system-wide, and then we will be able to install packages. That is, I suppose, missing in the official installation guide, but now you know. You don't need to install any other prerequisites to your whole system. Alright, now that installing our gems has wrapped up, we can continue with our installation. So now we want to initialize our database. So we install the gems. Oh, just a quick note there, if you can do bundle -jn for bundle after install. The -j usually is the number of threads. So if you have a 4-core CPU, you can multi-thread this. The server we're using is single core, so it really doesn't matter for us. But if you have access to it's a faster server. If you're going to run a lot of instances on this, for example, and you choose a model up of your instance. So now let us create the database and then migrate it to the latest version. So this will set up all the tables and all the sheets that you need for Huginn to work properly. Alright, now we are going to run a dbc. So this is important. This is going to be your official username, login, and password. So for example, if you don't want your login name to be admin, now is the time to change it. I will conveniently make it another randomly generated 16-digit character. Okay, if you do forget it, you can get it to regenerate you a new login, so it is not the end of the world. Also, we can now generate our read secret. In case you're not familiar, if you add a bundle exec, then it will run based on your local instance. So if I, for example, show what's in here, all of the Ruby gems that are needed for Huginn are being installed separately for this. It's like how you can have node modules installed per project rather than system-wide. So if I was to just install it to my computer, then it would be available for everything, but the Huginn specific ones are Huginn only. Hence why you need to do a bundle exec rake, because a rake is installed for Huginn, but not for the rest of the computer. So I'm going to re-edit our end file and change our app secret token. Alright, so we have our seeded username and password. Now it's time to compile all of our assets. So these are the static files and stuff that will, JavaScript bundles that will get served. So similar to how you might use Browserify or Webpack to compile assets together so that they can all be made into one bundle, and then we can ship that. Okay, so that's done. Now we need to edit proc file. So there are a couple things we need to change. So these first 2 lines are good for dev use. You do not want them because we are running this on a production instance. We want to actually use these 2 lines. A quick note: make sure you don't leave a space. If you leave a space before them, you will get weird errors when you try to actually execute this. So yeah, just comment out development and deploy production. Now export the init script. Every time you change something, you will need to export. This will create the RUnit things that we need. So that's perfect. Now we can set up log rotate. Now we can check to make sure that this is running. And log rotate that we did there will just make sure that logs don't fill up. And you can see that our unit is in fact running our processes properly. This whole process, following the official guide on Ubuntu, fairly straightforward. The moment you stray from this and you're on Arch, took me a week. Okay, we will use nginx as our server. You can use Apache if you prefer. I would suggest that if you're still running Apache and you're mostly serving static files, it may be advantageous to swap to nginx. So let's set up the default site config. So if you were using Apache, you would have your virtual sites under /etc/Apache, or when I say Apache, if you are running CentOS or Red Hat, it is called HTTPD, same program. So if you have Apache, you have these plugins that you would use on Ubuntu and Debian called A2NSite to enable a site and A2ThisSite. Similarly, you have A2NMod to enable a mod, and you have A2ThisMod. Now those are Debianism. That's not officially part of Apache. So if you make a virtual site, by default that is done under /nginx, etc/nginx/nginx.conf. For example, if I do a sudo etc nginx, one of our first lines here is include /etc/nginx/modules enabled, and then similarly for all of our sites we have an include /etc/nginx/sites enabled. So what we actually do where we link sites available to sites enabled is just a convention. If I wanted, I could change this to be sites available, and that way I would not need to run this ln-ls. Or you don't even need separate site configs. You could take all of your site configurations and copy paste them here into this main file, and it would work just as well. We just prefer to make it modular so that we can add sites in the future. So that being said, by convention, we will link our sites available to our sites enabled for our Huginn. Sites available, and here you can change this based on your needs. The default configuration is actually quite same, and thankfully Ubuntu and Debian ship nginx fairly configured, so you shouldn't have to do any large amounts of modification, unlike on some other operating systems that I will not name. So by default, your server name needs to be where you are hosting this. I don't have a domain name that I'm dedicating, although I could make one for this tutorial through our DNS. So I will just use the public DNS of this instance. Alright, again, if you are running this as a virtual host on the same server as you are on a bunch of other sites, set this to be what your domain name is. So that might be huginn.tonytascioglu.com or huginn.yourname.com or whatever the virtual host that you want to use for this is. Alright, we set the root, so this is where files will get served from. So it's going to get served from Huginn public. If you're on Arch Linux likes to put root web apps under /usr/share/web apps, and you will make a folder there. Again, depends on your setup. It doesn't have to be under your home directory. Client max body size, this is the maximum post request that you like. So this is maximum file size that you can transfer. If you're going to be uploading pictures and such, increase this from 20 megabytes because you will probably start getting weird errors. Alright, so this is especially important if you are setting up something like Nextcloud or Pydio, something where you need to or where you expect to consistently upload and download files. These are nginx access and error logs. Personally, I usually disable access logs just to not spam it, and I don't care. Error logs are super useful when debugging though, so I would recommend keeping it. And here, this just means that when someone goes to slash, it's going to try these files in order. As for location here, so this is literally just a proxy, reverse proxy, so that when something comes in, it'll transfer it over to our Huginn instance. Alright, we will disable the default site, or I'll choose to use unlink / and we want to unlink default, and then we can delete default should we choose. If you wanted HTTPS, the nice way, the easy way to do it is you can use certbot, and it'll use Let's Encrypt. It'll give you an HTTPS certificate, SSL TLS certificate, and then you can use that to enable HTTPS. Since it is 2020, I would highly, highly, highly recommend it and encourage you to set up HTTPS on your website. Alright, let's just make sure nginx config looks good and it's successful. So now we can do a systemctl restart nginx. Yeah, their official guide tells you to use sudo service, doesn't matter. Alright, so our site should actually be live now. So let's open up a new tab in Firefox, grab our public DNS, and you can see that when I go to our instance, we are greeted with the Huginn default screen. If you use no script, make sure you whitelist your directory so that JavaScript code can run properly. So your Huginn instance is successfully up, so we should be able to log in with our username and password reset. That is our username, and our password is super secret, and we're in. So Huginn ships you a bunch of default instances that you can use to test. Again, I'll show you a video on how you can use Huginn to make something like scrape a website, get the COVID-19 numbers or something, and then maybe email you with the results. Or you can send messages via Telegram. It's super flexible. You can basically use this similar to how you would use something like Zapier. The objectives are different. Zapier is a lot more integrated with different commercial apps, where this is much more, where in Zapier you would just have a flow. So okay, this goes from here to here, this goes from here to here. You don't have that in Huginn. You do this much more manually, should I say. So you'll have something to read a site and it'll output an event. And then you'll have something that takes in an event, does some processing on it, maybe runs it condition, or alternatively it'll reformat it to be in the order you want, and then it'll output that event. And then finally you will have something that receives an event and sends it out to you, whether that be an RSS feed or update your website or send you an email or Telegram bot, or you can even use something like Twilio to send you SMS alerts or give you a phone call. Now you will notice that we are on HTTP, so we can just do a sudo apt install certbot. Let's just get certbot and then we'll figure out the plugins. It will have to install Python 3. We have plenty disk space, so that's not really an issue. Alright, let's do, you don't even need to install their PPA anymore. You can just go Python, certbot, nginx. Well, if you spell nginx correctly. Alright, so let's just do sudo certbot. So there are a couple ways you can do this. You can choose to just get a certificate and then you will manually configure it, or you can let certbot just do it automatically. So it's asking for an email address. Okay, we agree to their terms. I'm already part of their mailing list. Let's not sign up again. So when you get here, it will list you all of the server names it has found. So if you have 50 different virtual hosts and virtual sites on your server, this should go through the list. It should find every instance of your domain names, every server that's on you. Historically, Let's Encrypt did not do a wildcard certificate, so if like me, you had a bunch of virtual sites, you had to manually just set all of them up. Nowadays, Let's Encrypt does allow the use of wildcard certificate, so you can technically authenticate anything under your domain. So if you had a huginn.yourname.com, anything.yourname.com would be good. So let's just pick one, and we will get an error for our case because we are doing this on Amazon and it is forbidden by policy. That is absolutely correct. If you are running this on your own domain name, then that would be a good place for you to set this up. And you can literally just follow the automatic config. At the end, it will ask you if you want to redirect all HTTP requests, HTTPS. So if you choose no, users will manually have to enter HTTPS:// otherwise they will get served HTTP. Thankfully, Google Chrome, Firefox are changing their defaults. I generally prefer to redirect, so anyone that's connecting over HTTP will get served over HTTPS. There's also a couple of other notes. For example, certbot will set you up for TLS 1.3 and 1.4, so vintage IE computers will not be able to connect. That's fine, it's more secure this way. And finally, just a couple other notes. If you, for example, I use Huginn with an ESP8266. In that case, you may choose to not redirect it because the poor ESP struggles when trying to connect over HTTPS occasionally. So usually I have it just fetch over HTTP so that I can just give it like a JSON feed, and then you use the JSON Arduino library to parse it. I did a live stream actually on this a while ago. Maybe I will make an ESP8266 programming video in the future. Let me know if that's something you would like to see. Alright, so just to give you some inspiration of what you can do with your Huginn instance, I'll show you just a couple of the things that I use my instance for now. Let's take a look. Okay, so here I have all of the stuff that I run off of my Huginn instance. So you'll see there's quite a lot happening actually. So I'll just show the diagram view. So a couple major flows I have. So first of all, for example, I have Open Weather. Open Weather will automatically fetch the weather. It'll scrape the JSON, get the events I'm interested in, and based on that, it'll do a digest. So it'll collect all of those events together and currently it sends them to an ATTiny it just uses liquid formatting to put it into a JSON object so that I can easily parse it on the other end. I called it an ATTiny. It's actually an ESP8266 now, because I figured that why have a separate chip to act as an Arduino when you can just use the ESP as the Arduino itself. So that's super cool. So it gets sent to an ESP8266, and then I'm setting up a display and stuff for it so I can make like a dashboard. This is actually still in the works. I'm going to have it also send me weather via Telegram and via email. For example, another flow I have is I get the latest coronavirus numbers, COVID-19 numbers, from the Government of Canada webpage. So there is a list. If you go to canada.ca/coronavirus, you can get the count numbers. And for example, because it's all in a table, you can easily scrape that and get all the numbers into a JSON object. So for example, this does two things. I convert it to be used with an ATTiny, and then I also have a formatter. And what the formatter will do, so if you can see, every time there's a change on the website, I will get the latest count numbers from my lovely bot that I have set up. It's also good for a couple other things. So for example, I have it also send me pictures of the weather radar, so I know if it's going to rain or not that day. So that's super useful. Well, it's more so just fun and curious. So that's just an example of what you can do. So that goes to the formatter, and for example, the formatter sends it to Telegram, but then I also make a digest. So the difference is when you're scraping an array, so like this is an array of objects, it sends one event per item. But for example, I don't want one email per row there, which it's fine with the messages because there's a character limit. But so what I actually want to do then is when it's happening via email, I want to make a digest so it'll collect all the events and then send a single email out. And then there's a separate formatter, and it'll send it to family emailer, which just sets the parameters for who is going to receive the email, and it sends it to mail to go. I used to use SendGrid. I ran out of credits, so I use mail to go now. So the mail to go has a convenient HTTP like REST API that you can use to send out emails, and it's from a trusted source, so it doesn't land in people's spam bins, and it's worked better than SMTP. I also have the weather radar that, as you saw, goes to Telegram. Scraping Canada Computer's best-selling page, just an example. You can then format it into something useful, send it to Telegram. The TTC alerts are just off because everyone's home. I'm not using the TTC now, but I have TTC, so every time an alert comes out, status update comes out on their webpage, the one that everyone knows. Every time an alert comes out, you can check if it contains some keywords that you're curious in, like line 1, line 2, or the routes that you take, and I have it send me notifications. Alternatively, every morning, I also have it collect all the alerts for that morning, and this will normally send me an email. And this way, I just know before I leave whether I have to take an alternate route. So for now, this has been how to install your own instance of Huginn. Thank you all so much for watching. If you have questions, comments, you can leave a comment down below. You can send me an email. If you don't want to watch this on YouTube, this video will be uploaded both to my PeerTube instance at peertube.tonytascioglu.com and to YouTube. Let me know. Share what you are using Huginn to do, how you have stuff configured. Thank you so much for watching, and I'll see you all next time.